Hello. In this lecture, we'll look at the packet capture for authentication header, and understand how the packets are getting parsed by both sides. We will also look at the configuration of the two routers. So here I have two routers that are 10001 and 10002 connected to a network. And there's a network behind router 1 which is 10110/24. And behind router 2 we have 10120/24. We want to use authentication header for traffic that's going between the two networks of 10110 and 10120 networks. So if we look at the configuration, basically the setup is first we have to do the IKE version 1 policy. And we will do show run find section crypto. We see crypto map. ISA-CAMP policy is using triple DES and the default hash is MD5. We will use pre-shared key. Crypto ISA-CAMP peer is 10002. This is the peer authorization entry. Cisco is the pre-shared key and we specified that peer with IP address 10002 uses Cisco as the pre-shared key. The transform set is the configuration of phase 2. It uses AH with MD5. The crypto map is the security policy database. It specifies that, if traffic matches access list 100 it should be sent to peer 10002. The access list is using wildcard mask and specifies if the packet source begins with 10110, and if the destination begins with 10120, then it will go to that peer. It will reach the peer 10002. We attach this crypto map to interface Ethernet 00. So router 2 has the same configuration but flipped to the opposite direction. So, let's run a capture and look at the authentication header packets. Let me go ahead and run a capture on this interface here. I will trigger traffic by pinging the other side 10.1.2.1 with source 10.2.1.1. We should see the main mode messages. The 6 main mode messages, 1, 2, 3, 4, 5 and 6 are exchanged. Then we have the quick mode that establishes the phase 2 setup. Then we have the 3 quick mode packets. And then you have the authentication header packets. So if we look at the authentication data packet, this is the frame. This is the actual layer 1, this is layer 2, which is Ethernet source and destination. And then you have after that the IP header. The IP header is 20 bytes. And inside the IP header, it lists the next header down, which is pointing at authentication header. That's the protocol after the 20 bytes. And then if you look here, the total length is 144. So it's 144 times 32. This is 4068 divided by 8. That gives you 576 bytes. That's the minimum length of an IP packet. So, that's the total length of the packet including everything below it. And then we see here after that, so we know that the next header is authentication header. Inside authentication header, you see the next header that tells you what's the next protocol. Here the protocol number for this is IP encapsulation. The length, this is the total length of the authentication header, that's 18 in hex. 18 in hex is decimal 24 times 32 bits. That's going to be 768 bits divided by 8, this is 96 bytes. This is total size of this header. And then you have the original packet that was sent, which is the ping packet. The ping packet between the source and destination 10111 to 10121. So this is basically the original packet that's encapsulated. If you look at the authentication header, you have the security parameter index that lands that traffic on the correct security association. And then you have the sequence number that increments. So the request reply pair has the same sequence number. The second request reply has different sequence number. This is incremented. So, it is incremented by 1 for every pair of request response. And then you have the ICV, the integrity check value. This is the outcome of hashing everything below the authentication header with the hashing algorithm agreed upon, which in this case is MD5. And it's going to put the outcome in this ICV field. So when the other side receives the packet, it looks at the content below the authentication header. It runs the same calculation and arrives to the ICV value. And then it compares the two values. If they're equal, that means the traffic did not change in transit and the traffic checks out. Integrity of the traffic was validated. So when a packet comes in, you have the layer 2, and then you have IP, and then AH, and then the original packet. It gets received by the other side, the receiver. Alright, so if we look here, first, the IP header is 20 bytes. And inside this, the source and destination of the gateway, and inside that, it's going to specify that the next protocol is AH, which is protocol 51. And the receiver would know that the next header is 51. So the receiver is going to pass what's after the 20 bytes to be the authentication header. Inside the authentication there is the ICV. And then after the authentication header, you have the original packet. So it knows that this is authentication header. It knows how to pass it. It passes it, because it knows the length of this is 96 bytes. So this is 20 bytes. And then you have 96 bytes. It's going to look at the 96 bytes. It will extract the ICV. It knows that everything after the 96 bytes is going to be the original packet. So then it extracts the original packet. And then it runs the hash algorithm and comes up with its own ICV calculation, and then compares the two. And if they are equal, everything checks out. Because this is authentication header, there's no encryption. We can actually read the original content of the packet. In the next lecture we will look at ASP and compare it with AH. See you in the next lecture.